Okay, welcome to 9.2 in Math 20-1 example number 2. And it's just a slightly, uglier isn't the right word, but it is a slightly more difficult quadratic. We're going to solve it the same way though. And I think, talking about graphing and factoring, those are the skills we need to cultivate in grade 11 to succeed in grade 12. And I know that's such a, on the soapbox thing to say, especially when you can't see me, but it is really important that the techniques we're teaching you in Math 20 are more or less just a means to an end to be able to, learn Math 30. Which I don't want to, take away from the difficulty in 20-1, but it is really important that most of what this course is building, the skills that are required to learn more and more difficult math. In this particular question, what we need to do, just like example 1, is we need to graph this inequality, and then where the graph is below the x-axis will be the solution because it is less than 0. And I'm just going to put that means it is below the x-axis on the graph y equals negative x squared plus x plus 12. So much like our linear inequalities, when we do graph these, we want to make sure that we're graphing a function and then attaching a deeper meaning to what we're actually seeing on that graph. Now, the best way by far of factoring this, and I'm just going to write y equals negative x squared plus x plus 12, because that's what we're going to try to graph here. I am going to factor out the negative 1. That leaves me with x squared minus x minus 12. And then what I can do is I can factor the inside of that bracket to be x minus 4 times x plus 3. So that's two numbers that multiply the constant negative 12 and add to the coefficient of the x term, which is negative 1. From this point, and I'm going to identify this, that we now know my x-intercepts are at 4, 0 and negative 3, 0. The other information we know is right back up at the beginning. I'm just going to put, and it says it in the question, that the a value of this quadratic is less than 0. So we know that the quadratic opens down. And just to be as completionist as possible, what's the y-intercept? Hopefully it's as easy as inspection. It is at 0, 12 for this particular quadratic. Now that is enough, especially for a question like this. That information tells me all that I need to know. It tells me when my function is 0. That's here at negative 3. And over here at positive 4. I also know that it goes through 0, 12. Somewhere up here is totally acceptable. And then I can graph this. Now, if you want the full picture to get where that vertex occurs, you would actually need to use your calculator for that. I'm not overly worried about doing that. So I'm just going to draw this quadratic as opening down and roughly passing through. I missed that last one just a little bit, my last point there. Now, in the context of this question, keep in mind that my red graph is negative x squared plus x plus 12. And I'm just going to put that my function is greater than 0 when it's above the x-axis and less than 0 when it's below the x-axis. Now, this particular question wanted to know when negative x squared plus x plus 12 is less than 0. Not equal to 0, though. So in blue here, the solution is going to be an open dot on that negative 3 and everything to the left of it because my function is negative or below the x-axis there. It's also going to be from positive 4 and everything greater than it because, again, my function is below the x-axis over that interval. And I want to kind of summarize that the solution to this, negative x squared plus x plus 12 is less than 0 when x is less than negative 3 or x is greater than positive 4. Very important that the inequality matches the question. Now, what I mean by that is in the original question, this was less than 0, not less than or equal to 0. So in my answer, it should be less than or greater than, not less than or equal to or greater than or equal to. So when we do have that less than or greater than nature in our question, that should be reflected in our solutions as well. So a bit of a harder question. Make sure you are using your calculator if you're struggling with doing that graph without, but you do want to get comfortable with quadratics that you can factor this and bare minimum find the direction of opening, the y-intercept, and the x-intercepts. When these are really, really ugly numbers, the calculator is certainly acceptable. But remember, you can always use that quadratic formula to algebraically get x-intercepts, even when they're ugly rational numbers or irrational for that matter as well. Okay.